Today, I'm going to walk you through how we build and deploy a modern AI-powered application using Heroku's new AI Platform as a Service tools and capabilities. The app we'll explore is Luminaire Solar, a platform for a solar energy company that serves both residential and commercial customers. Through this portal, users can shop for solar products and track their energy production and usage to understand their savings month by month. In this demo, we'll focus on how developers can use Heroku to build powerful applications and APIs with a spotlight on developer tools and the developer experience, including AI assistants and IDE integrations, AI services with Heroku Managed Inference and Agents and a Heroku MCP server, deployment automation using CI/CD pipelines, an overview of the next generation of Heroku, including Open Telemetry support, enterprise-grade features like private spaces, Heroku data, and integration with Salesforce and Agentforce through Heroku Connect and AppLink. Here's how Luminaire Solar built their application. A fast, modern front-end using React and Vite. A scalable backend using Node.js and Fastify to handle business logic. Heroku Postgres to store metrics and application data. Heroku Managed Inference and Agents powered by Cloud 3.7 Sonnet to run agentic operations and analyze data using Heroku-supported tools. Private spaces to ensure secure networking and data residency. Integration with Salesforce and Agentforce using Heroku Connect and AppLink. And observability with a Java monitoring worker with Open Telemetry support. At Heroku, developers are at the center of everything we build, and one of our greatest strengths is the developer experience we are known for. Developers can deploy and manage applications using a wide range of tools, the Heroku CLI, and deployment with the renowned Git push Heroku main, directly from GitHub using CI/CD pipelines, through the Heroku dashboard for a visual browser-based workflow, from the Heroku extension for Visual Studio Code, bringing Heroku directly into the IDE, and with AI-powered workflows in editors like Cursor connected to the Heroku MCP server. No matter the preferred workflow, Heroku provides a seamless experience across the entire app lifecycle, from development to deployment and management. In this example, we are deploying the Luminaire Solar frontend using the Heroku MCP server inside Cursor. With a simple AI prompt, we are asking it to deploy to the staging environment. The MCP server handles the process, first creating the Heroku application, then setting up a CI/CD pipeline to manage future deployments automatically. Once the pipeline is created, we'll ask the agent to deploy the staging application to Heroku. After that, we'll head over to the Heroku dashboard to finalize the setup. Now that the basic pipeline for the front-end application has been created using the Heroku MCP server, let's link an existing application as the production app in the pipeline. Next, we'll enable continuous integration by connecting our pipeline to GitHub. This allows the application to be automatically deployed whenever code is pushed, and ensures the test suite runs as part of the process. We'll also enable review apps, a feature that creates temporary live environments for each pull request. This lets developers test new features in isolation before merging them to staging and promoting them to production. After setting up CI/CD and review apps, we'll enable automatic deployments for the staging application. This means every time a new commit is pushed to main, Heroku will automatically deploy it. We'll also enable a test check, ensuring that deployments only happen if the test suite passes. This helps prevent broken code from reaching staging. We can also promote the staging application to production directly from the Heroku Pipelines dashboard. This action automatically moves the application to production without triggering a rebuild. With Heroku ChatOps, you can manage your deployments and pipelines right from Slack. It is a simple way for teams to stay in sync without jumping between tools. From Slack, you can deploy your pipeline to staging, and once everything looks good, promote it to production, all with a few commands. ChatOps also checks that your GitHub commits pass their tests before deploying, and it logs the deployment status back to your pull requests so your team has full visibility. It is a clean, collaborative way to manage deployments directly where your team already communicates. A Dyno is where Heroku application runs. It's a lightweight, virtualized Linux container with allocated CPU and memory resources. From the Heroku dashboard, developers can scale up or down the number of dynos and adjust the dyno formation based on the needs of the application. With the help of the Heroku MCP server, managing your Heroku application becomes even easier. Using natural language prompt, you can ask the AI to scale your application. No commands needed. You can see the updated dyno count and formation reflected in the Heroku extension for Visual Studio Code, which offers a convenient way to manage your Heroku application directly from your IDE. And it is not just scalability. You can also provision a database or any other add-on using the Heroku MCP server. In this case, we are asking to provision a Heroku Postgres database and attaching it to our application, all through a simple AI prompt. There are other ways to provision add-ons, both official Heroku services like Heroku Key Value Store and Apache Kafka for Heroku, and third-party add-ons such as Papertrail, New Relic, Twilio SendGrid, or Elasticsearch. You can provision these directly from the Heroku dashboard, where you can also choose the plan that best fits your application needs. All available add-ons can be found in the Heroku Elements Marketplace, where you can browse them by category, review features, and install them directly to your application. In the Elements Marketplace, you can find add-ons in categories like data stores, monitoring, logging, email and SMS, errors and exceptions, content management, and many more. Let's go to the data stores category and go to the Heroku Key Value Store add-on page. From this add-on page, we can install it directly to our application. We later use Key Value Store in our app to manage caching. One of our most recent and exciting offerings is Heroku Manage Inference and Agents. It allows you to build AI-powered applications without the usual operational complexity. It brings together the core building blocks needed for modern AI development. Simple integration of AI models, support for agentic workflows, seamless interoperability between AI services and Heroku's dynamic infrastructure, and extensibility through tools like the Model Context Protocol, MCP. Heroku Managed Inference can be attached to your application just like any other Heroku add-on. You can choose from a variety of models, including Cloud 3.7 Sonnet for inference, Cohere for embeddings, and Stable Diffusion for image generation. You can also deploy an MCP server to Heroku and use it as a tool within your agentic workflow. Heroku's MCP toolkits provide an unified gateway to deploy and manage multiple MCP servers on the platform without the operational complexity and adding security on top of it. This gives agentic systems like Cloud Desktop, Cursor, and Heroku Managed Inference and Agents a consistent and secure interface to call APIs and interact with resources, whether they are running on Heroku or externally hosted. Now that Managed Inference and Agents are enabled in our application, let's test it by running an inference prompt using the Heroku CLI. After running the Heroku AI Models Call command, we can see that the inference returned a response. Now let's see how can we add this to our Luminaire Solar application. Luminaire Solar uses Heroku Managed Inference and Agents in two key ways. One, as a headless agent to analyze solar system performance based on weekly weather forecasts. And second, as a chat assistant that answers questions about Luminaire Solar's products, services, and customer data. For example, if we ask about energy savings across all systems, the agent, powered by Managed Inference and Agents, will automatically query the Heroku Postgres database by running the Postgres get schema and Postgres run query tools. Then analyze the data using Python through the code execution tool. And then generate a custom report on the fly using the LLM generated code to create a chart to show the requested information. All of this happens in a secure, isolated environment, ensuring your data and credentials remain protected. From the Heroku dashboard, you can monitor the health of your application using a comprehensive set of metrics. These include memory usage, routing health, latency, load, and also language-specific metrics to understand the performance of your application in the specific runtime. In the case of the Luminaire Solar backend, we are running in Node.js. You can also enable threshold alerts to notify you or your team if the application begins to experience performance issues or degradation. For example, recently, Luminaire Solar has been experiencing performance degradation in its backend application. To diagnose the issue, a developer uses the Heroku MCP server along with an AI-powered IDE. The MCP server retrieves the logs and identifies that the problem is caused by excessive logging in the production environment. Using the assistant, the developer prompts the AI agent to help diagnose the issue. The agent identifies excessive logging as the root cause and recommends updating the logging strategy. The developer then asks the assistant to modify the code accordingly, updating the logging configuration to prevent this issue from recurring in production. Once the fix is in place, the Heroku MCP server can be used to deploy the updated application to staging, then promote it to production. Finally, run another health diagnostic to confirm that the performance issue has been resolved in production. Now let's move on to Heroku Data, one of our most powerful offerings. Heroku operates one of the largest managed PostgreSQL services in the world. Let's open the Heroku Postgres dashboard for the Luminaire Solar backend. From here, you can monitor the health of your database and review the I/O metrics, analyze expensive queries to optimize performance, manage backups, create database followers, and perform rollbacks. You can also set up private link connections to securely connect to your database from outside a private space, and much more. You also have access to data clips, a read-only interface for querying your database. With data clips, you can explore the database schema, write and share SQL queries with your team, generate basic reports, and export results in CSV or JSON format. Another powerful Heroku product is Heroku Connect, which allows you to set up a bidirectional sync between Heroku Postgres and Salesforce data. Luminaire Solar uses Heroku Postgres to store product information, but they are now integrating with Salesforce. In this example, we'll show you how Luminaire Solar can easily bring Salesforce data into their application using Heroku Connect. First, we'll add Heroku Connect as an add-on to the backend application. Then, from the Heroku Connect dashboard, we will do the following. From here, we need to establish a connection to a Salesforce org, the one we want to synchronize to. Let's choose the Heroku Postgres database, the schema where the Salesforce tables are going to be created, and then we need to authorize the Salesforce org, selecting the environment, the API version, and then going to the login page in Salesforce. Once we enter the credentials, the connection has been established. Now it is time to create the mapping. Let's go to the Mappings tab. From here, we will click on Create Mapping, and a list of all available Salesforce objects, including custom ones, will appear. For this demo, Luminaire Solar is interested in mapping the product to object. So let's go ahead and select that object from the list and go to the mapping setup page. From here, we can choose the polling frequency to bring in data into Heroku Postgres, set up the direction of our synchronization, if it's going to be bidirectional or read-only. If it is bidirectional, meaning we are going to give write access, we will need to establish an external ID. Then for Luminaire Solar's use case, we will only bring in the fields needed by the application, like the product description, the image URL, the product code, the family, etc. Once we select the fields, let's go and save the mapping. After saving the mapping, Heroku Connect begins synchronizing. We can view the sync data by going to the Explorer tab. Here we can see the rows that has been synced, and if we expand on one of those, we can see the fields and the data that it brought. Finally, we can go back to the Luminaire Solar products page. If we refresh, we are going to see the newly synchronized products from Salesforce that are now appearing in the application. Now let's talk about private spaces. Heroku private spaces are network-isolated, dedicated environments designed to run applications and data services securely within Heroku. They offer a private and controlled platform-as-a-service experience, ideal for organizations with strict requirements around data protection, change management, and compliance. You can create a private space in any of the 10 supported regions. Private spaces can also be configured with either standard isolation or shield, which is intended for high compliance workloads such as those requiring HIPAA or PCI standards. Now let's create a new private space using the third generation, the Kubernetes-based runtime. Let's select the Virginia data center for this space. Luminaire Solar has built a new .NET Worker application to monitor solar energy system performance and report metrics to an Open Telemetry collector. With Heroku's new support for .NET and Open Telemetry, this application can now be deployed seamlessly to Heroku and benefit from enhanced observability and modern runtime capabilities. Let's create an application on the new Luminaire Fair space. Then we will deploy from the CLI using git push Heroku main. During deployment, the application is automatically built using cloud-native build packs, producing an OCI-compliant image ready to run. Then, using the Heroku CLI, we can add a new OpenTelemetry drain to our application, or even configure it at the private space level. This drain will receive traces, logs, and metrics from our .NET application, allowing us to monitor its behavior and performance in real time using an OpenTelemetry compatible observability tools. Now that our drain has been configured, we can open our OpenTelemetry collector dashboard. In this example, we are using Grafana to visualize the metrics, logs, and traces sent by our application. This gives us a clear view of the application's performance and help us quickly identify any issues. Now let's take a look at how Luminaire Solar integrates with Salesforce Data Cloud to unify and activate customer data across systems. Salesforce Data Cloud is a data platform that allows organizations to bring together information from Salesforce and external sources to create a single source of truth. In this case, we have seen the Luminaire Solar data stored in Heroku Postgres with Data Cloud using the Heroku Postgres connector. We also configured the web connector to bring in user behavioral data, like browsing history and future usage. This allows us to build unified customer profiles with a full 360-degree view of how customers are interacting with Luminaire Solar across platforms. Once the data is unified, we can act on it in several ways. Generate calculated insights for analytics and segmentation, create data actions to drive event-based orchestrations, trigger Salesforce flows to automate internal processes, and deliver real-time personalization in Salesforce apps. This integration shows how Heroku and Salesforce Data Cloud work together to turn operational data into meaningful customer-centric insights and actions. We have already seen how to bring data from Salesforce into our Heroku application. Now let's look at how to expose Luminaire Solar's API endpoints to Salesforce using Heroku AppLink and external services. With Heroku AppLink, developers can build APIs on Heroku that Salesforce admins and developers can call directly from Flows, Apex, Data Cloud, and Agentforce. The add-on supports multiple user modes and respects Salesforce user permissions and rules, ensuring secure interactions when accessing data or using Heroku SDKs. Let's add the Heroku AppLink add-on to the Luminaire Solar application and connect it to Salesforce using the Heroku CLI. Once the org is authorized, we can import an Open API specification that describes our API. This automatically generates a Salesforce client and handles all the setup and authentication for us. After the import is complete, we'll see that the Luminaire services are now available in Salesforce API Catalog, where we can see all the available operations as invocable actions, so they can be used in Flow, Apex, and Agentforce workflows. As an example, let's create a new flow in Salesforce to fetch Luminaire Solar products stored in the Heroku Postgres database through the API. To do this, we'll add a new flow action, then search for Luminaire services. This will show the list of all the imported actions from Heroku AppLink. Let's select Get Luminaire Products. Then, we need to assign the success response to a new variable. Once we configure the new variable, it is time to test the integration. We will run the flow in debug mode. And as you can see, we get a successful response with the JSON output from the Products API endpoint on the Luminaire Solar backend, confirming that Salesforce is now connected to Heroku through AppLink. Now let's set up an Agentforce agent to use the newly imported services. In this example, we want a service agent in Salesforce to diagnose the performance of a solar energy system by accessing application data and metrics stored in the Luminaire Solar Heroku app. This is a perfect use case for Agentforce, as it allows Salesforce users to securely trigger actions and fetch data from external systems. To do this, we will create a new Agentforce action, selecting the reference action type as an API, the reference action category as Heroku, and this will display a list of available API actions exposed through Heroku AppLink. We'll choose Get System Metrics and complete the action setup. Once it's configured, we can test it in Agent Builder by asking the agent to fetch energy metrics for a specific system. Just like that, Agentforce is consuming data from the Luminaire Solar Heroku backend, thanks to Heroku AppLink. This demo has shown how Luminaire Solar leveraged the full breadth of the Heroku platform to build and operate a modern, AI-enhanced application. We have covered a modern architecture built with React, Node.js, and .NET. Scalable infrastructure using Heroku CI/CD pipelines, private spaces, and our next-generation runtime. Integration of Heroku AI Platform as a Service capabilities, including managed inference, agents, and the Model Context Protocol to enable secure agentic workflows. Robust observability through Open Telemetry. Deep Salesforce integration via Heroku Connect, AppLink, and Agentforce, enabling data and action flow between Heroku-hosted systems and Salesforce. This end-to-end setup demonstrates how Heroku provides a secure, extensible, and developer-centric platform to accelerate AI-powered application development while meeting the operational and compliance needs of enterprise organizations. Thank you.